Given the function f of x equals x cubed minus 6x squared plus 9x, find the x coordinates of the inflection points. Now, the inflection points exist when the second derivative is equal to 0. That's where change of concavity occurs. So, let's find the first derivative. F prime of x is going to be power rule 3x squared, power rule negative 12x, power rule 9. The second derivative is going to be power rule 6x, power rule minus 12, power rule nothing. Set that equal to 0. 0 equals 6x minus 12. Let's add 12. Let's add 12. Cross you out. 12 equals 6x. Divide by 6. Divide by 6. X equals 2. So my one and only inflection point is going to be at x equals 2. Easy peasy lemon squeezy. Given the function f of x equals 2x to the fifth minus 5x to the fourth plus 10x cubed, find the x coordinates of the inflection points. Inflection points exist when f double prime, or the second derivative of x, equals 0. So we need to take the first derivative and take the second derivative, set it equal to 0, probably do some factoring, and then take it from there. So f prime of x, the first derivative is going to be power rule, so that's going to be 10x to the fourth, minus power rule again, 20x to the third, plus power rule again, 30x squared. Now let's take the second derivative. F double prime of x is going to equal power rule 40x cubed, power rule minus 60x squared, power rule plus 60x. Now let's factor what we can factor. F double prime of x, I can factor out a 20, I can factor out an x, and that leaves me with 2x squared minus 3x plus 3. Now this is fun, because here we have an obvious point at x equals 0. Try to factor that out. You can't. See, if I set this equal to 0, which I forgot to do, so 20x 2x to the second power minus 3x plus 3. If you do the zero product property, yeah, you get that x equals 0. You can't factor that out. That's not factorable. So I'm going to bring back an old friend called the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a, singing a song. You're my A, you're my B, you're my C. So x is going to equal negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 3 all over 2 times a, which is 2 times 2. Now, let's write that out. X equals positive 3 plus or minus the square root of 9 minus 8 times 3 is 24. Now, that is a problem, because you're going to get the square root of a negative number. These are imaginary. Oh, no. So if these are imaginary, you only have one inflection point, because these are not real numbers. So my one and only inflection point is x equals 0. After all of that, lame city. But that's how you do it. If f double prime of x equals negative 6, then we may conclude that. All right, so what happened here is there must have been some f of x that was some type of polynomial. Then you do the first derivative, you get the second derivative, and you land on this. So what you're supposed to do is you're supposed to find inflection points. Well, finding the inflection points has you setting 0 equal to negative 6 and solving for x. There is no x, which means there's no inflection points. So basically what we have here is we are told that the second derivative is just a regular old negative number. Okay? In intervals where the second derivative is negative, tells us that it's concave down. So this entire derivative Second derivative, from negative infinity to positive infinity is a negative number, which means it's concave down for all values of x. So kind of a strange problem, but that's what it means. If f double prime of x equals x minus 1 times the quantity x plus 2 cubed times the quantity x minus 5 squared, find the interval where f of x is concave down. Well, normally what you do is you take the function, you take the second derivative and set it equal to 0 to get your inflection points. This is already the second derivative. So I'm going to take this guy and set it equal to 0. Now here's the thing. Whenever we see multiplicity, that means something strange is going to happen. All right, so my inflection points are going to happen at x equals 1, negative 2, and positive 5. So we make ourselves a sign table for f double prime of x. And my magic numbers are negative 2, 1, and 5. We take numbers that are not within those, that are within the interval. So I'll take negative 10, plug it in. I'll take 0, plug it in. I'll take 3, plug it in. And I'll take regular 10, plug it in. And see if we get something that's positive or negative. Okay, in the intervals where it's positive, that means it's concave up. In the intervals where it's negative, that means it's concave down. So what I need to do is take all 4 of these numbers and plug them into my second derivative to see what I get. So f double prime of negative 10, I don't care about the actual answers. I just care if I get something that's positive or negative. So I'm going to have negative 10 minus 1, which is negative. Negative 10 plus 2, which is negative, squared, and negative 10 minus 5, which is negative, cubed. You become a negative times a positive times a negative, which is a positive. So this area is going to be positive, which means concave up. Okay, let's try it again for 0. F double prime of 0 is going to be 0 minus 1, which is negative, 0 plus 2, which is positive squared, and 0 minus 5, which is negative cubed. That's negative times a positive times a negative, which is interesting, positive. Now the reason why that's interesting is because we had even multiplicity. Oh, actually, no, that's odd multiplicity. Oh, super strange how that happened. Super strange indeed. So you are positive, which means you're concave up still. All right. F double prime of what else? 3 is going to equal 3 minus 1, which is positive. 3 plus 2, which is positive, squared. 3 minus 5, which is negative. So I'm going to get a positive times a negative cubed, which is going to be a positive times a negative, which is a negative. So you are concave down. How nice. And then if I plug in 10, I'm going to get 10 minus 1, positive. 10 plus 2, positive. Squared. 10 minus 5, positive. Cubed, giving me positive, giving me positive. So the only areas, the only interval where this is concave down is going to be between 1 and 5. That's it. So kind of a strange problem. Kind of a strange problem. But yeah, that's how you do it. If f prime of x equals x minus 1 times the quantity x plus 4 squared, find all values where f of x is concave up and increasing. So let's deal with that guy first. Okay, when something is increasing, what you do is you take the function, you find the critical points, and you find out where the derivative is positive. Okay, so I already have the derivative, so I can find the critical points. So the critical points are going to be found by setting this equal to 0, x minus 1, x plus 4 squared, and finding out what my critical points are by doing the zero product property. So x equals 1 will do it, and negative 4 will do it. So let's make a sign graph for f prime of x, and this will help me find out where this guy is increasing. So my magic numbers were negative 4 and 1. So what I can do is I can plug in negative 10, I can plug in 0, and I can plug in regular 10. So f prime of negative 10 is going to have me doing, and this is what I'll do. I don't care about the numbers. I care about whether it's positive or negative. So this will be negative 10 minus 1 is a negative number. Negative 10 plus 4 is also going to be a negative number. Square that. Negative times a positive is going to be negative, so you are negative. Okay, so not increasing there. Let's plug in 0. F prime of 0 is going to be 0 minus 1, which is negative, 0 plus 4, which is positive, squared, and a negative times a positive is a negative again. So there's no, there's a critical point, but there's no like max or min going on here because it goes from negative to a negative. But that's not what I'm supposed to do. I'm supposed to find out where this is increasing. So let's plug in 10, and that's going to be 10 minus 1, which is positive. 10 plus 4, which is positive. Square it is positives all around. So you are finally increasing. So this is increasing on the interval 1 to infinity. Now I have to find concavity, which requires me to take the second derivative, and in this case I want concave up, finding out where it's positive. All right, so in order to do the second derivative, I'm going to use product rule. So u would be my u would be my v. So u prime would be the derivative of x minus 1, which is 1, and v prime would be, good old chain rule. So you drop down the 2, keep the inside, and then multiply everything by the derivative of the inside, which is just times 1, so I'm not going to change anything there. All right, so f double prime of x is going to equal u prime v, which is u prime, which is 1, times x plus 4 squared, plus v prime u, so 2 times x plus 4, u, which is x minus 1. Ugh. All right, so I'm probably going to have to do some foiling. Unless I want to do this instead. Watch what I do. This is me thinking outside the box. That 1 is not necessary. Okay, that 1 is not necessary. I have an x plus 4 and an x plus 4 in common with both, so let's pull it out. X plus 4. That leaves me with an x plus 4 here and a 2 times x minus 1. Okay, so by the way, that's f double prime. I don't know if I remembered to do a second thing there. Yeah, I think we're good. F double prime of x is going to equal x plus 4. So this will be x plus 2x, so 3x, and then 4 minus 2 is going to be plus 2. So setting that equal to 0, I have inflection points at x plus 4, 3x minus 2. Let's be cute here, negative 4. If I add 2 divide 3, I get 2/3. Okay, so let's make a sign chart involving the numbers for negative 4 and 2/3. So I can plug in negative 10, I can plug in 0, and I can plug in regular 10. Okay, so let's do the same thing that we did here with that guy and do f double prime of negative 10. That's going to be, if I'm going to use this equation right here, that's going to be negative 10 plus 4 is negative, negative 10 times 3, that's going to be negative still, so a negative times a negative is a positive. So your positive, which is concave up, okay, I'll put positive because I'm trying to be consistent, not just the plus sign. Positive. If I plug in 0, f double prime of 0, I get 0 plus 4, which is positive, 0 minus 2, which is negative, so you're negative. And if I plug in 10, I get positive And then 3 times 10 is 30. 30 minus 2 is still positive, so positive. So I want concave up. You're concave up here, and you're concave up here because of the f double prime sine graph. So I'm increasing from 1 to infinity, and I'm concave up from negative infinity to negative 4 union, and then 2/3 to infinity. So kind of a mess of a problem. And when I say kind of a mess of a problem, it's a mess of a problem, just like I am making a mess trying to circle it. But there you have it. Concave up here, increasing there, fun everywhere.